the first two parts, the first 1A, 1B should be very straightforward. I'm hoping. 1C maybe it's interesting. You can redo it all and just take forever, or you can realize one quick little thing. So number one, what's the? Oh, it's not that one. There's. What's the relationship I can use for part A? What's the volume formula? This is another cone, right? So it's going to start off as 1/3 pi r squared h. But then what do I know? The diameter at the top is 40, so of course that means the radius is 20. And the height is 60. So wherever this water is, whoa, shit. How'd I go, Jeff? So I want you to do a few of these to get used to this, because they do show up a lot. These cones show up a lot. So we can do just like we did before. What relationship can you show? Can you set up here? Yeah, over h equals 1/3. I like it. So r is 1/3 h. Now don't forget this. This is useful even after we plug it in. Maybe for step C. So for part A, it's just going to be volume is 1/3 pi 1/3 h squared h. So it becomes 1/27 pi h cubed. Is that cool? Well, that's in terms of h, isn't it, Jeff? So this one we should write as 3r. So I mean, this is what you could use for part C if you wanted to, but I actually say screw that. So now I'm going to replace h with 3r, and that really becomes nice. This becomes pi r cubed. That's beautiful. So that's the volume in terms of the radius, not the height. So part B now, they ask me, what rate is the radius? So part B, I know what I'm looking for is dr dt. What rate is that changing when the, and it's saying shrinking when the radius is 16 feet? And what do they tell me at the very beginning? dv dt is that freaky 48 pi cubic feet per second. Yes, but you can either put an explicit negative, or you can realize that your answers are going to be decreasing or whatever. The explicit negative might be a good idea, just to remind you that it is. That's why I'm asking at what rate is the radius shrinking, because now I'm letting water come out, so of course the radius is going to shrink as you go down the cone. I like it. So now I just got to take this dude, derivative, so I have places to throw things. So what's the derivative of that dv dt equals 3 pi r squared dr dt. And now I can throw stuff in, solve for what I need. Let me stop there for a second. Okay. I look at this. You all have these faces like, I have so many questions that I'm not going to ask. Just to be that way. All right. So I know dv dt is 48 pi. So the pi's go away. That's nice of Jeff. Thank you, Jeff. R is 16. I'm trying to solve for dr dt. So divided by 3 is 16. Divided by 16 squared, one of the 16s go away. I think some of you guys just have resting quizzical face. I don't know what it is. Divided by 3 is 16. Divided by 16 squared, one of the 16s cancels. So you get 1/16. What is dv dt? dr dt. I can't even write today. What's the units? Feet per second, because it's in this case I'm talking about radius, which is a linear measurement, right? How we doing so far? Is that? So now I know dr dt is this, at a time when r is 16. So look at part C says how fast is the height changing when the radius is 16 feet. But don't I have this relationship? Doesn't this mean that dh dt equals 3 dr dt? Do you guys see that? This is, again, I love to show you this example. Any relationship that is true, if I take the derivative, I get a true relationship between the rates of change of those things. That's the basic idea behind this. This is why I construct a formula that describes everything, and then I take derivatives, because now that's true also. That's how the rates are related to each other. Well, bam, I got this little tiny dude. I know what dr dt is. I'm asking what dh dt is. Bam! It's 3 times dr dt. So you could kind of redo this whole thing using this to figure out what dh dt, or you can just use this little dude right here. Either way you do it, you should get 3/16. So here I get dh dt equals 3 times that, 3/16 feet per second. Okay. What about number 2? Do you guys see how that's got something interesting? There's got a multi-layer thing going on. There's multiple ways of taking care of this. You guys got what you want from this here? All right. More than you wanted? More than likely. So who got somewhere in part B? Number 2. What do you do? First off, what's the for? What's that in symbols? The 4 cubic centimeters per minute, that's going to be what symbols? What notation? dv dt. Right. So dv dt is 4. Blah, 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 blah. How fast is the surface area shrinking? So I want to know ds dt, surface area. That's what they're asking for. When the radius is 24 centimeters. So what's kind of the problem here? I gave you 2 formulas because you need them. You know how volume and radius relate. You know how surface area and radius relate. But what you really need, so to figure this out, if you just take ds dt, what's ds dt from its formula? S equals 4 pi r squared. You know that, Jeff. Oh well. What's ds dt? Yeah, so this comes down, it'll be 8 pi r times no, dr dt. That's the thing I just took the derivative of, right? Chain rule. So what's the inside function of the square? R. So that's what has to have a chain piece done, right? Don't get overly excited and just think you can just throw the other thing in there, right? So they're asking me what this is, but what do I need to know to figure out what this is? Do I have everything I need? Do I have R? Yes. Do I have dr dt? Shit. All right, so then, so you see, that's why I said earlier, you write down the formula they're in what they're interested in. There it is. Take a derivative. See if you got everything. I don't got everything. That means I got to do some side work, and that's why we have a whole other equation. So I've got this equation too. Right? Goes to Syria. So now I can get a relationship between dv dt and dr dt. I can solve for dr dt, and I can plug that shit in there. You see, this is just a multi-layer. This is you've seen these kind of things in algebra, the multi-layer algebra. Here's a multi-layer calculus one, of course. dv dt equals surface area times dr dt. Now, one thing to notice about this that's interesting, that's S there, right? But, oh, so can you solve for dr dt now? Do we have everything we need? We know dv/dt, yes, 4. We know r is 24. So now we can solve for dr/dt. The 4's cancel. I get 1 over 24 squared, which is, I don't know, 288, 144 times 4, so 576, is that it? 576 equals pi, equals dr/dt. And now I can take that and throw it in there. So this is a situation where they didn't tell me directly the piece I need. I had to go back and calculate the last piece I need. Okay, it should seem very familiar. You have to do this many times in your math history. So now I can finally figure out what this is. ds/dt equals 8 pi times 24 times this weird shit. Galilei arrow. The pi's cancel, that's nice. This was, sometimes if I'm going to throw this shit in somewhere else, I kind of leave it unmultiplied. Because you see how there 24 cancels, right? Wasn't 576 24 squared? Yeah. So obviously this goes into it 24 times. And then 8 goes into it 3 times. So ds/dt equals 1/3 somethings. 1/3, I forgot what the unit was. Centimeters per minute. Yes, it's the surface area, Jeff. Thank you. Thankfully, you don't have to keep track of the units through the problem, but if you did, they would work out to the correct stuff. But otherwise, you just, like you just did for me, if it's area, it's always got to be squared units. It's probably a good idea. Okay. How do we feel about that, you guys? I'm trying to expose you to the kind of problems you could see. You could have a very direct one. You could have this multi-layer one like this. You have to figure out part of what you need on the side. And then you can have, of course, you're not going to get away from trig stuff. You know that, especially with me. Because I'm a nice person trying to maintain your trig stuff for you. Has anybody tried number 3 out yet? Shit. Well, I kind of want to let us out a little early. How about we do 3 next time? You guys can try it out on your own if you want to. The nice thing is, looking ahead a little bit, we already sort of did most of 310, to be honest. I just got a few formal things I've got to define for 310. And then 311 is a section that a lot of my colleagues skip, and you're like, God damn, if I would have known this stuff, I would have taken somebody else. But you will appreciate me going over this. It doesn't make any sense for people to skip this. It's hyperbolic trig functions. And you're all like, sure. But we'll see. Nothing too crazy. Okay.
So today we did 3.7.
We did 3.7. We didn't do 3.8. 3.8's out. 3.9. And we've already done some of 3.10, to be honest, yeah.
So we're not going to
No.
With this, how do you become RQ? Because R equals 3 pi and you plug it in.
No, R equals 3, let's see,
3 pi.
H equals 3R.
That's not up here. So R equals 1 over 3H.
Yeah, R
You
equals
arrange
1/3
it.
H. So H equals 3R. So if you replace H with 3R, R times R is R cubed. And of course 3 times 1/3 is gone. That's why I've got the pi R cubed. So I had a pi R cubed up here. How did I get there? Because it's 1/3 of
Pi R
Yeah, okay. I forgot what shape was pi r squared h. And we know that, what was it, radius,
So the pi over h equals.
yeah, so radius is 1/3 h, meaning that the height is 3r. So if you just plug that in place of h,
Wouldn't be 3r.
1/3 pi r squared in place of h. H is 3r. R is being squared.
Oh.
H is just h. See that?
Yeah, so you multiply.
Yeah, so 3 times 1/3 is gone. R times r is r cubed.
Oh, okay.
Yep.
I thought you just multiplied it. Oh, okay. Alright, thank you.
Sure.